Good afternoon.
Good afternoon, sir.
Uh, yeah, shall we go ahead and start? Or still your friends has to come? Have you intimated them? Any one of you? If your
Yes, sir.
friends, please
Yes,
intimate.
sir.
I'll wait
Coming,
for
sir.
another. I'll wait for another 2 minutes. Okay, I'll start. These are typical problems we'll solve. 1 or 2 typical problems today. Problem statement is like this. First, I'll read out the problem statement. Before that, let me read the figure and sketch of the problem. Are you making a note of this or just merely seeing what I am doing? I will be
Noting,
not
sir.
noting it. You show me. Once you show me, then I will provide you the videos. You show me what have you noted down, then I will provide you the videos. Everyone show me, all 18 students, I will provide you the videos. I have all the recorded videos with me. The problem statement is like this. A bar ABC is shown in figure, consists of two parts, AB and BC, having area of cross section 300 mm square, 300 mm square, and 400 mm square, and 400 mm square. It is rigidly fixed at NDA. It is rigidly fixed at NDA, and at NC is at NC is at a distance of 1 mm from the other rigid support. The distance from here to here is 1 mm. It is not coming into contact with the other rigid support. There is a gap between this support and this BC, the part C by 1 mm. Okay. A load of 100 kilonewton is applied vertically downwards at B. Determine the reactions produced by the rigid horizontal supports. I will call this as RA. And if you want, you can call this, if you want, you can call this as RB. In the first question, you ask, determine RA and RB is equal to how much? The stresses in part AB and BC, sigma AB and sigma BC is how much? These are the two questions. So in this type of problem, so now can anybody tell me, always you should remember, only when there's a constraint for deformation, only when there's a constraint for deformation, stresses are induced. For example, if I take a bar like this, and if, yes, in this case the stresses are induced. For example, okay, if I apply a load, this is not a suitable example. I have to give in context to thermal, but time being you understand it. For example, how can I give you the rigid body displacement? Oh, let me explain with this example only. See, in this A, B, and C, two parts, section 1 and section 2, when I apply a load of 100 kilonewton, the part AB is under deformation. The part AB undergoes deformation, isn't it? The part BC will not go any deformation. It will move like a rigid body. It will not undergo any deformation. It will move like a rigid body unless and until comes into contact with this rigid support. Once if it comes into contact with this rigid support and load is still enough to push this below, then the stresses are built up. Are you able to understand this? Let me repeat again. When I apply a load like this, the load is at the center. When I apply a load at this point B, at this point, the part AB is subjected to stresses. It will undergo deformation. Whereas the part BC is under, it is like a rigid body. Due to the deformation of AB, it is moved like a rigid body without any deformation. Up to what point it will move like a rigid body without deformation? Up to the point when it comes into contact with this rigid support. When it comes to the contact of rigid support, then due to this load, then compressive stresses may be induced in this part. We will not worry about that. But you should know that the part AB, the part BC is under rigid body displacement unless and until it comes into contact with the fixed boundary condition. When the load is still high, then the stresses are induced. Okay, now once if these types of problems are given, the first thing what you should do is you should find whether the section AB is undergoing deformation more than 1 mm or not. You cannot say this deformation is more than 1 mm. You cannot directly say that. First you want to find deformation of section AB. DL of AB is equal to PL by AE of AB. PL by AE of AB. So in this type of problem, there is 100 kilonewton load applying. Okay. Okay, give me a moment. Okay. The load applied on this section, the load coming on this part is, give me a moment. I cannot, give me a moment. Okay. See, what I will assume that is that the load what is acting at this junction is elongating part AB. So I will assume this 100 kilonewton acting on AB 100 into 10 power 3 into length 1500 divided by area of cross section. It's 300 into Young's modulus he has given as we'll verify this also. Young's modulus he has given as 200 GPa, 200 into 10 power 3 MPa MPa, or you can, if you are not still convinced, Newton per mm square, 200 into 10 power 3. Cancel this 10 power 3. Tell me what is deformation of AB. Tell me what is deformation of AB. 100 or 15 into 10 power 4 by 6 into 10 power 4. Cancel out. 6 2s are 12. 3 remaining, 2.5 mm, right? 2.5 mm. So deformation of this part AB is 2.5 mm. Since 2.5 mm is greater than 1 mm, the section BC is under compressive. It has to be compressive stress. Under compressive stress. Need not to worry. Is under compressive stress. But can you tell me what is the maximum deformation these two bars, these two sections can undergo? Only 1 mm. If this is 2.5 mm tension, then this will undergo 1.5 mm compression. Therefore, the total deformation is only 1 mm, right? Since if the deformation of AB comes only to be equal less than 1 mm, say 0.75 mm, then there won't be any stresses induced in part BC. Since this deformation is greater than 1 mm, then and only then the stresses will be induced in part BC and also in part AB. If this is less than 1 mm, AB will be under stress and BC will move like a rigid body. There won't be stresses induced in part of BC. That you should understand. Okay. Before doing the problem, you should verify whether the part BC is undergoing any stress or not. Before only, if you get more than one, whatever the gap, more than gap or equal, more than gap, you should get more than gap. If just equal to gap or more than gap, equal to or greater than gap, then only the stresses will be induced in the member. Okay, so we'll go ahead and solve the problem. Stresses DL total is equal to DL AB. Sorry, before that this is 1 mm and this is equal to 100 kilonewton. As usual, A, B, C. I will take the section at AB. If you want to take the section, this is RA, and if you want, you write your RB. If I take, you can take anyhow you want the section. Let me take the section in this fashion. Okay, I will see how anyhow any way you can take the section. I will take the section in this way. You understand from this. I will take the section like this. This is section. This is B. This is 100. This is acting away from the normal acting away from the cross section PAB. Summation of force in y direction is equal to 0. PAB minus 100 is equal to 0, or PAB is equal to 100 kilonewton. This you can do. Okay. Next, I will take the section here. I'll take the section here. Then I'll write give me a moment. PAB is equal to 100 kilonewton. Hold on. Give me a moment. There's a little small confusion. I will go ahead. Give me a moment. Okay. I will go ahead. I'll go ahead and take PBC. Let there be a reaction force since this this is greater than 1 mm. The deformation is greater than 1 mm. I will take PBC. This RB reaction force coming into picture. I have to take RB. Therefore, PBC is equal to minus RB. Right? Next same DL total is equal to DLAB plus DLBC. The maximum deformation can be only 1 mm. Okay, only 1 mm. 1 is equal to DL of AB. AB is 100 into 10 power 3 into length 1.5 meter, 1500. The area of cross section, it's 300 mm square, 300 into Young's modulus 200 GPa plus, shall I write, minus RB into 10 power 3 into 1500 divided by 400 mm square is the area of cross section. 400 mm square, 400 into 10 power 3. Can you calculate and tell me what is RB? Is it clear? Is it clear?
Yes, sir.
Hello? Right? Clear?
Yes, sir.
Okay. Tell me what is RB? You can indicate that by RB by RCU also, but I have taken RA and RB.
Minus 0.26.
Minus 0.26. Huh?
Yes, sir.
Calculate properly. 1 is equal to 100 into 10 power 3, 10 power 3, 10 power 3 cancel out. 26 point something you should get. In a moment. 10 power 3, 10 power 3 can cancel. 10 power 3, 10 power 3 you can cancel. Calculate and tell me 15 into 10 power 4 by 6 into 10 power 4 minus RB by into 15 by 4. How much are getting? 15 by 6 minus 15 by 4. How much are getting? This sorry, 1. This is 1. How much are getting?
2.5 minus 3.75.
1. There is only 1 no, right? 2 point
2.5.
2.5.
mm.
I got 6.4, sir.
6.4. Yengri. Okay. Give me DL total is equal to 100 into 10 power 3. P of AB is minus 100 into 10 power 3. Length is 1500 m. 1500. 300 into PL by C. I have missed 200 here. Okay. 400 into 10 power 3 into 200. Now tell me. Okay, I missed that. Sorry, make correction. You're not conscious. By 8 into 10 power 4. Tell me. RB equals how much? How much? Hello?
$60, sir.
Correct ಹೇಳಿ 60
Exact
65.74
60. Exact
65.7
60.
check it properly 100 into 10 power 3 1500 nothing we have done wrong. Check it properly. We have to get RB minus 34.28 kilonewton. RB minus 34.28. RS 65.714. Check it out. Others? Others? How much are you getting? How much are you getting? Hello? How much you are getting? ಎಷ್ಟು ಬರ್ತಾ ಇದೆ? Hello? Are you
Sir,
there?
answer didn't same, sir.
Huh?
Same, I got same 60 only, sir.
60 only. Where we have done wrong? Can you tell me? 300 into 200 minus into 1500 by 400 into 200. 8 into 10 power 4. 15 into 10 power 4. Okay.
Sir, I got 80, sir.
Correct. Tell me the right answer.
Sir, RB, I got 80, sir.
Its exact answer is minus 34.286 kilonewton.
No, sir, not getting, sir.
Not getting? Give me a moment. Let me calculate. I will also calculate. 8 you are getting, right?
Yes, sir.
8 you are getting, right? 8 you are
Yes,
getting,
sir.
right? Okay,
Yes,
okay.
sir. Yes, sir.
Where we are gone wrong? Give me a moment. P of AB. Same. What happens is P of BC. See, shall we see what I have done is I have taken by granted the reaction force. This reaction force I cannot take directly. This reaction force, even though it is not coming into contact, it will come into contact and more than that. But I have taken reaction force to be granted, like PBC is equal to RB, and then I have taken above that all that. Okay, I have not taken this reaction force into consideration at all. That is the problem. Shall we do other way around? Shall we do other way around?
Okay, sir.
Okay. See, what happens is I cannot take directly the reaction force RB coming on this section BC. What I can do is, let me show. What I can do is, this is the exact method. This is how we have to proceed. I thought initially like that, but since I initiated, I could not be able to go in that method. There is no contact directly, so I can't just directly take that. I'm writing. Let us take this as RA, this as 100 kilonewton, this is A, B, C, 1 mm. Shall I take the suction here? Shall I take the suction like this? This is how the suction has to be taken, because RA, it is actually in contact. RA, it is actually in contact. This is how this problem has to be done. RA is actually in contact. RA is acting like this, and P of AB acting like this. So RA minus P of AB is equal to 0, or P of AB is equal to RA. Next section I will consider like this. 10 minutes remaining. Next section I will consider like this. I will write RA P of BC 100 kilonewton. Okay. RA minus 100 minus P of BC is equal to 0, or P of BC is equal to RA minus 100. If I take one more, another 40 minutes, will you be able to engage? We will solve another two problems. Will you cope up? Shall I continue for another 40 minutes? Hello? Hello?
Okay, sir.
Okay. PBC is equal to RA minus 100. Now if I take deformation total is equal to P of AB RA into 1500 by area 300 into 200 into 10 power 3 into 10 power 3, which is equal to, sorry, plus RA minus 100 into 10 power 3 into 1500 by length 400 into 200 into 10 power 3. Now tell me what is RA. Since that was not coming into contact, there is no contact between this suction and this RB. Still, even though I took that RB is coming into contact and we did the mistake. That should not be taken. This is how this problem has to be proceeded. Tell me what is RA now. What is RA?
Calculating 7, sir. I got minus 30, sir.
Minus 34.286. RA 65.714. Why? It has to be 65.714 kilonewton. There's nothing wrong here. The first meter we did blindly, that was it was an error. But this we should get 65.74. Check it out.
Okay, sir.
Are you getting it?
Sir, 65.71.
Yes, that's the right answer. 65.714. Send to the second link. You can log in within 5 minutes. After 5 minutes, you can log in into the second link. It's on 345. Okay, it's RA, which is equal to 65.74 kilonewton. Now, if I write what we got, PBC is equal to RA minus 100. Okay. Let us assume RB in this direction. However you want, you can assume RB in this direction. RA minus 100 plus RB is equal to 0. Summation of forces in y direction is equal to 0. RA is 65.714 minus 100 is equal to minus RB. Tell me what is RB is equal to minus, shall I write 34.28 kilonewton. It means to say that my RB, what I assumed, is not acting in this direction. It is acting in this direction, 34.28 kilonewton, downward direction. It is not in the direction what we have assumed. It is acting downwards. Okay. Next, he has asked us to find sigma AB and sigma BC. This is straightforward. Sigma AB. Is this clear? Is this conceptually, is it clear? If I take the section here, what happens is, if I take the section here, what I have done here, I have not considered this reaction force RA into picture. I have not at all considered reaction force into RA into picture. You can neglect it, but I cannot consider reaction force here. It is not coming actually into contact. I can't blindly take RB coming into contact, but I thought we can do like that, but it cannot do like that. It has to be done in this fashion only. Okay. Next, sigma AB, which is equal to PAB by AAB. Sigma BC is equal to PBC. PBC. What happened? PBC by ABC. By PBC by ABC. Tell me sigma AB and sigma BC. PAB, what we got? PAB is equal to RA. Therefore, PAB, which is equal to how much? RA, what we got? 65.714 kilonewton. PBC, therefore, PBC, which is equal to 65.74 minus 100 minus 34.28 kilonewton. Obviously, this member will be under tension, this member will be under compression. The part AB will be under tension, part BC will be under compression. This is how we have to solve. Okay, PAB 65.714 into 10 power 3 by 300 minus 34.28 into 10 power 3 by 400. Tell me what is this value. Therefore, sigma AB is equal to sigma BC is equal to.
Sir, next class is at 3:45 or 2:45, sir?
Scheduled at 3:45. Oh, okay.
Yes.
Rescheduled it. You can log in after 2:45. If this after this class completes. How much you got?